Welcome back to Breaking Changes, where we highlight what's going on in the Qiskit universe. I'm your host, Nick Braun. This episode covers the release of the Qiskit Auth.43 meta package, which includes an upgrade to Terra Auth.24. Qiskit Terra will soon take the place of Qiskit. See the request for comments link in the description below. Before we get to the new features, let's review the deprecations, of which we have some big ones. Shed a tear for Qiskit OpFlow. The module formerly known as Operator Flow once served as a collection of tools for operators and state functions that provides the language between circuits and algorithms. This functionality can now be found in the Quantum Info or Primitives modules, hence it no longer provides unique functionality. Now pour one out for the Quantum Instance class, a utility for configuring, transpilation, and execution of quantum circuits that is closely tied to OpFlow. This has been replaced by the Qiskit primitives. Instead of .execute function of quantum instance, use the primitives-based sampler.run or estimator.run. The .transpile function should replace with the transpile method from Qiskit.transpiler. And .assemble is no longer required, and so it has not been replaced. Algorithms utilizing the quantum instance are also deprecated, however many have been refactored to use primitives. Some of these are available from the same namespace, meaning your code will continue to function without modification, while others may have new import paths. When you find that to be the case, which will be at least 3 months from now according to deprecation policy, there's an algorithm-specific migration guide, as well as an OpFlow and quantum instance-specific guides in the description below. In features news, dynamic circuits now support switch statements. Similar to its classical counterpart, it allows case-based testing in addition to if-else for faster execution time, which is very important for qubit latency. Let's take a look. From Qiskit, we import our quantum circuit, quantum register, and classical register, initialize our quantum and classical register, and then build a quantum circuit utilizing both of those. We'll do a Hadamard both on qubit 0 and 1, and then do measurements on qubit 0 and 1 and store them in the appropriate classical register. And then if we want to feed forward on the result of that measurement, we can use this switch statement qc.switch on the classical register as case and enumerate the cases. If 0, 0 is measured, represented by the decimal 0, we'll add a z-gate to qubit 0. If the case 0, 1 or 1, 0 is measured, corresponding to decimal 1 or 2 respectively, we'll do a C0 between qubits 0 and 1. And for any other measurement, we can add a Hadamard. This gives the circuit here. For more complicated binary representations, we can use the integer function to switch between binary and decimal by doing int 0, 1 in base 2 and int 1, 0 also in base 2, which will give us the same logic. The switch statement is currently being incorporated into the OpenQASM3 specification. In transpiler news, another forward-looking feature is the support of disjoint coupling maps. In our future world of modularity, this will allow techniques such as circuit knitting that allow the partitioning of circuits to run on several separate quantum processors that only have classical links between them. Other transpiler features include a Rust-based performance improvement in the transpiler and a pass for loops in dynamic circuits. Additionally, a whole host of bug fixes were made to the OpenQASM2 exporter, so you can now use it with abandon. And lastly, let's thank the Qiskit contributors that made this stable release possible. I've been your host, Nick Braun, and thank you for dealing with the breaking changes.